Hi, I'm Dave Pheteplace with Bishop and Associates. I'm here today talking with Sjon from Mentor Graphics. Sjon, what are some of the key things that you've been working on?
We're working on a thing called harness manufacturing process management. Basically, all wire harness manufacturers, they get a design from some sort of engineering source. They have to break it down into sub-assemblies and eventually the raw material that builds that wire harness up. Well, the processes that go into that actual process have to be broken down by some type of a process engineer, and they're typically very manual processes. Usually an engineer is doing it with some drafting tool, or if they've got something sophisticated, it's still not data-centric, and it usually doesn't have the ability to reuse anything, very limited automation. It also tends to be very time-consuming. We've had one customer who actually quoted us that the cycle time for a change was 6 months. That means a customer has given them a change, and 6 months later that customer finally gets a product with that change in order. As you can imagine, that's quite a bit of a disadvantage for that company.
So your product gives them a good advantage then in that part of the process.
Absolutely. So we just introduced last year a new product called Harness MPM, Manufacturing Process Management, as you might expect, that does exactly that. So it's a data-centric solution. It actually bolts right onto our existing Capital tool suite, which is all about defining, designing, and servicing products to begin with. And it helps those manufacturing processes break down that wire harness design that engineering has handed them and do it automatically. So a lot of automation, a lot of reuse. Since we're using a data-centric solution, it gives us all of those capabilities. Also, since it's off the shelf, a lot of the smaller companies, they don't have the IT infrastructure to build something. So buying from a commercial vendor, we can get the feedback and the understanding of what the problems that your suppliers, your customers, even your competitors are dealing with. So we can incorporate that into the tool. It's also very customizable. So no two manufacturers are going to be the same. Not even two plants within the same organization are going to be the same. Also, you're not going to be the same throughout time. So the ability to customize those operations and those structured bill of materials is very important, and that's what Harness MPM offers our customers.
Okay, Sjon, would it be possible to give us a little demonstration of the product?
Absolutely. I have a colleague that can give you a demonstration of Capital Harness MPM.
Great.
Capital Harness MPM is a highly automated, highly flexible manufacturing process modelling tool that operates on Capital Harness XC design data. And the tool allows organisations to model each of the process steps involved in harness creation as reusable operations within the tool, and it's provided with a number of operation templates that cover all the manufacturing aspects from wire processing through to final assembly. And the sequence of operations that constitute a full manufacturing flow are added to and are managed as patterns. Each of the operations is designed to analyse and group specific component types and harness structures, and can be further fine-tuned and configured using the parameters and conditions built into the operation templates, and fully defined operations can be stored in libraries for reuse later on. SBOMs are automatically created for a harness based on the analysis of a harness design against a selected pattern. So here we're going to create a new SBOM for this harness. We can pick from one of the potentially many patterns that an organisation may have in order to create an SBOM. And the result of the process is an SBOM which is shown as a fully expandable, searchable tree. And the content at any level in the tree can be previewed via the dimmer functionality. Here I can see if I switch on the dimmer, we can see the top level harness, pieces of the harness, and within those harnesses pieces we can see the connector sub-assemblies and their individual wires and components below that. Should any manual edits be required to maybe rebalance some components from one sub-assembly to another, this is fully supported via the use of simple drag and drop functionality. Here for example we have an assembly and a similar assembly there, and we may choose to move this connector into the other sub-assembly, and via the drag and drop the component is simply moved accordingly. And an extremely important additional aspect to this functionality is the ability to preserve any manual edits when reprocessing an SBOM as a result of a design or a pattern change. So for example, if we choose to regenerate, we're prompted that we can preserve the manual edits that we just created. And if we expand again, we can see that that connector assembly is in fact still where we manually moved it. The next step in the SBOM lifecycle is to assign part numbers to each subassembly, as is typically required by a factory's ERP system. Capital Harness NPM automatically generates and assigns part numbers to each of the unique subassemblies, and whilst doing so identifies common subassemblies, and where identified allocates the same part number. There we can see the part numbers have been generated. And this identification of common part numbers enables organisations to benefit from economies of scale. For example, where a particular wire or terminal combination is already being manufactured as part of a different harness, maybe in the same factory or even in a different factory. The powerful extensibility features embedded in all Capital tools allows for the creation of all kinds of powerful reports and viewing utilities for the SBOM. So here we can see a navigable tree structure view of the SBOM that's cross-highlightable with the design browser to allow the user to focus on any interesting section of the SBOM. And various reports can also be configured. In this case, a summary of the total quantity of each subassembly. We can have one that identifies the detail of each subassembly, or here's a navigable one where we can click on any given subassembly and see the detailed content. And ultimately, the data associated with an SBOM needs feeding into a company's ERP system, and so here the use of Capital Integration Service functionality could be used to create a direct interface, or the data could be accessed via the standard export utility, which in turn would create an XML file of the full structure of the SBOM.
Okay. Sjon, thank you very much. That was very interesting. It sounds like it presents some really good solutions to your customers.
Thank you.